Hello, my mathematicians. This is Miss Foster with first grade three-dimensional geometric solids work for the week of April 20th. Friends, the major geometric solids that you are asked to learn are in this very first picture. Cube, rectangular prism, although a cube is a rectangular prism, and I bet you already know that there is more than one kind of prism. Why? Think about it. Cone, cylinder, which I think is the hardest one to spell, and pyramid. Now, I know that there are other geometric solids that you know or will discover, and if you want to go beyond this, you absolutely can, but this is sort of our starting place. And in the work this week, you're going to be asked to choose some activities that get you really talking about these three-dimensional geometric solids, because part of the big challenge here is learning the vocabulary. Now, as you are talking about these different shapes, you also are going to want to use this vocabulary to describe them. So in a geometric solid, if there is a two-dimensional flat plane, we call that a face. Kind of like your face is bumpy, but kind of flat. That's the two-dimensional part of the cube. Where the faces come together, we call that an edge. And on this picture at the bottom of the screen, you can see it in red. And where edges meet, we find a point that's a vertex. Now, a vertex is a no-dimensional object. An edge is a one-dimensional object. A face is a two-dimensional object, and you need all those dimensions to make this three-dimensional object. So those are some of the words that we're going to be using. Now, our Math in Focus textbook asks us to play around with geometric solids by building lots of different things and patterns with them. And there's so many options for what you can do that I'm giving you a choice this week. So this is your worksheet, and I'm asking you to pick at least two of these options to play with. First one, go on a geometric solid hunt around your house, looking for cubes, prisms, cones, cylinders, and pyramids. It's kind of a bummer that we're all kind of at home right now. So if you know that you saw one of these solids out in the world somewhere where you can't go right now, like this cone right here, anyone? So if you've seen that out in the world and you want to write down that I saw that someplace, you certainly can. We're not allowed to go on playgrounds right now, but it would be just fine to sit outside a playground and think, do I see any cylinders here, any pyramids? Perhaps you have the kinds of toys that we see down here. I have all of these toys in my house. You may have toys like these, and if you've got them, it's time to get them out and play. It turns out that children who play a lot with these kinds of building toys tend to have a richer understanding of math and visual spatial awareness that serves them well in the years of math to come. So perhaps you will be using these kinds of toys to either find or build different kinds of prisms or cylinders or pyramids. But perhaps you might just get into that Lego box of yours and start becoming a master builder. All of it helps you build your visual spatial skills. So get ready and go crazy. Now, if you build something out of one of these things, would you please take a picture of it? I still don't know how you're going to share work with me. We're still working on that at the Wellington School. But I would love you to take a picture so that we can share it eventually. And because learning the words is so important, please get an adult in your home to talk it out with you so you can practice talking about how many edges did you have? And how many vertices are in this shape? All that is a great way to develop that vocabulary. Another thing you can do, you can build what we call composite models, not just models of geometric solids, but models with geometric solids. And so here is the composite model. And for many people, when they look at this, it's hard for them to realize that there's a blue rectangular prism on the bottom. There are two green cylinders above that, and there are two orange cones above those. Just being able to figure that out can be a challenge. So using any geometric solids in your house, could you build a challenge to share with us? Here's another example from our textbook where you can see they've built all kinds of things. And here's the question. Based on the information in this picture, can you tell what that blue one is? It can be challenging, really thinking it out. You can see that for this challenge, they have used cubes, rectangular prisms, cylinders, and cones. When you create one of these composite structures, you can talk out at home how many of each did you use, and what does it look like from this side? Could you draw it this way? And then could you actually turn the thing in 3 dimensions and draw it from a different perspective? All of that turns out to be so important for your math brain. Now, the book also invites you to make patterns with geometric solids. And so here you can see that you can change the pattern by changing the solid. There are other ways to change patterns too. You could do it by size, by shape, by color. Maybe you've got a lot of the same shapes. You could make some nice Lego patterns there. You could change shape and color, and then here's the craziest one. You can change the shape, the size, the color, and the turns. Do you see how on this first circle at the bottom of the screen, the arrow's pointing up? And on here, the big blue triangle's pointing up, but then this flips around, so it's pointing down. So flips and turns are all part of developing your pattern understanding, and that's one of your choices today. It can get pretty tricky and you can be pretty creative. But the last one is probably my favorite, and I hope that you'll have a chance to follow the link that I put in the PDF that I've sent you to be placed in your Seesaw folders. I found this website that's put out by the National Council of Teachers of Mathematics, and they've created a site where you can explore 3-dimensional shapes. So you will run into some words that you may not know here, like a tetrahedron or an octahedron. Now at school with our origami, we talk about the dodecahedron and the icosahedron. So you can see these different kinds of shapes in here and play around with them. Let's go to the cube, just because it's one I'm pretty sure you know. You can color the sides. Oh, those are the edges, my goodness. You can color the whole face. Let's make that one green and this one dark green. And I'm starting to wonder, how many faces does this have? Now if you look over here, you'll see that there's a place for you to keep track of the number of faces, the number of edges, and the number of vertices, which is plural for a vertex. Well, so far I know that this cube has 3 faces. I seem to have skipped some. Okay, so I'm going to use color to help me decide how many faces that has. I think that's 4. And what about 5? I think I got them all now. Uh-oh, I need to get that one too. So I'm up to 6, and when I color them like that, I'm telling the computer program that I found the faces. And then I can check, are any of them still white? Pretty cool. I can also count the edges by getting my arrow right there. And you can see over here that when you highlight one, it starts counting them for you. So understanding geometric solids, their edges, their vertices, their faces, lets me show you how to get a vertex here. You put it right on the vertex and there it is. And you can see it's begun counting. You also can decide to make this shape transparent. And so the dotted lines are the edges that you can't see when it's solid. See that? You can also do it shaded, so you can sort of imagine what the light is like when you play with it. And there are many different ones that you can play with, but here's one of my favorite ones. We've played with this as a solid shape, but all solid shapes can be made by folding certain patterns that you cut out of 2-dimensional paper called nets. So being able to imagine what the net of a cube would be, it's pretty advanced visual spatial awareness here. So we're going to see what they think that this particular net would look like. Let's watch this. If you hit net, it will unfold it. Do you see that? Isn't that cool? And if I put it back to solid, we can see how they're kind of folding that all together. Whoa! And that's why this last one down here is one I hope that you'll try. You can make your own net, and you can take some shapes like this hexagon, and you can add other colors to it. And I really like this program because if I want to put this square here so that it lines up with that edge, if I just put it pointing at the edge, it puts it there for me. Isn't that handy? Now, if you wanted to line it up with the vertex, you can do that too. I made a mistake with that the last time I taped this video, so I can't exactly find it right now. But you can do that. I'm not going to show you how the whole thing works. You get in here and play. And then if you want to, you can print this out. And you'll be able to cut it out and actually tape or glue it together. When you do that and your parents talk to you about maybe putting some extra edges there that we could put the glue on, listen to them. That's the one thing I wish they had on this program, which they don't. So friends, thank you so much for playing math with me today. I love playing math with you. I miss seeing you at school, but I'm excited for all the fun you're going to have working this week with geometric solids. Bye-bye for now.